Hello. Today we're going to take a look at the Guardium Data Encryption technology. This is a data at rest encryption tool. This is important for organizations to be able to quickly encrypt their data, their sensitive information, prevent access to that data, all while not hindering the business with performance overhead, and doing this transparent to applications and business processes. Encryption is important for organizations because this gives them the ability to provide protection, compliance, and do this without hindering the business. So what we're going to go over today is a couple of use cases. We've got some file systems, and we're going to do some system level encryption, and we're going to demonstrate the policy based on access control. So we've got standard file data encryption. We're going to navigate some VIP or some sensitive file directories. We're going to look at authorized, non-authorized users, ones that can, like business processes and applications that need to see that data in the clear transparently. And then others will see that data as crypto or encrypted, and even denying that access from reading that encrypted data or the directories as a whole. This also works for highly privileged users and operating system owners like root and administrator. We also have the capability to do live data encryption. Live encryption on existing online databases or files that are currently being accessed. This is process automation. This accelerates the implementation of the technology. A lot of encryption technologies would require you to shut down the business, shut down the application of the database in order to encrypt the data. Guardium Data Encryption has the ability to encrypt data that's not currently being accessed or written to at the block level, and then reapply that encryption as soon as that application or business process is no longer accessing that data. It provides its own key management and key rotation, centralized key management. This is very important to accelerate the administration and lower the overhead of the technology. And then it's got logging and reporting capabilities, as well as integration with SIMs or syslogs to send this activity downstream to other areas. So the Guardium Data Encryption DSM, or Data Security Manager, is an appliance centrally manages and encrypts keys and policies. So we'll take a look at this. So the different domains in its own siloed security administration, and allows different departments to have their own separation sets of admins, keys, and policies for their own entities. In this example, the HR domain has its own set of administration keys and policies, and again, agent host servers. So we've clicked on the host button here, and now we're going to see the GDE agents that are installed. So from here, we manage all the GDE agent servers from one console, supported platforms on the Linux servers, and we're going to click on this Osprey acme.com to look at the protected guard points and policies applied. A guard point is a security bubble, if you will, around individual assets, folder paths, or folders. So we've got different policies can be applied to different encrypted file parts or file paths. In other words, these are the guard points. On this screen, we have a standard file encryption example to show encrypted VIP or sensitive file folders. Another example to show live data transform encryption on the database DB2 without having to bring that database offline. This is very important for operationalizing the technology and lowering that administration and lowering the time to get to the goal of encrypting the data, as well as not interrupting your business, no business disruption. So let's look at the VIP files examples first. So we're going to click on the guard point, guard GDE VIP files to continue. as you can see highlighted here. This screen shows 3 different users. So root users, the left side, and VIP users, the top right. These can access the protected paths and see the files within the directory. The user Dan in the bottom right is not an authorized user according to policy. Dan is denied access from the guard point and cannot see the files that are inside the encrypted directory. So if we click on the root window to see what happens when root tries to read the encrypted file. So the difference here is that root and VIP user can see the contents of the folder. Root, being an administrator, might need to perform some type of administration, but doesn't necessarily have to see that data or shouldn't see that data because it's a privileged user. If that account is compromised, then that user would have access to that data. So we'll click on the window here. And you can see that what happens with this is the data is now encrypted. So root user is able to read what's in the encrypted directory and in the metadata of the encrypted files, but performs the system-related work, like I said. However, when the root user tries to read encrypted file contents, root sees crypto text because the policy did not provide system root users with the key to decrypt the data. Now if we click on the VIP session information, again highlighted here, VIP user is able to read the customer file in clear text. This is because according to the GDE policy, a group of VIP users should have access to see and write data in clear text. Imagine that the VIP user is an application or a business process or a high-level user within the organization that does need to see the data in clear text. And so again, we'll click on this user screen here. This will take us back to the system so that we can see the actual GDE policy. This is the GDE policy applied to the VIP files of that guard point we saw earlier. So VIP users have apply key. This is important, and just permit. Permit would allow them to see what's in the directory, but apply key is what's going to decrypt that data in clear text. So this means they have that they have the encryption key to read and write the encrypted files in clear text. System root users group only have read permissions to the file metadata only. They can see the file creation date, file permissions, etc., but they do not have key. They do not have the key to read the data contents in clear text. The standard VIP key is the encryption key used in this policy. Key is centrally managed within GDE and can be rotated and maintained within the system. Okay, let's click on the OK box here. Next, we're going to see the live data transformation example. In this example, we will do a demo running a DB2 database and how we can encrypt the database files without bringing the database offline. Let's look at the VIP files example first. Click on the guard point, GDE guard DB2 to continue. So again, this is highlighted here. It's the second one. In this screen, root can see files inside the DB2 guard point, which is an encrypted database, as we showed in the last example, but the .lrg file is a large table space file used by DB2 engine, so it is actively being accessed. If being stolen and tampered with, hackers can potentially extract sensitive data in the clear. What this means is you can write a strings command against this file in the background and get the data out or see the data that's in the database without actually accessing the data. This is the difference of why you want to encrypt data at rest versus using, let's say, Guardium Data Protection to protect that data in flight for people inside the databases. All right, so if we click on the file .lrg to see the unencrypted contents when being tampered with. So this is that example where someone is able to access that data directly. So they're accessing the data at rest as it's been written to the storage or the disk. They're not actually querying the database. So if you're monitoring the database, this activity would not be captured. because this is outside of the database, data at rest. All right, it's worth to note that even though this example shows DB2 as an example, file system level encryption or other DBMS share the same concept. So this would happen for more than just DB2. This is also for really any database. Once the data is committed to disk, it's written to a table space on the file system and can be accessed. All right, so that was the unencrypted contents when database file is being tampered with. This is data from the actual database tables in the clear. Click on the table space file to see it in the encrypted view. Again, this is highlighted here. So this screen shows live data encryption in action. On the bottom right screen, we see a list of SAP applications and DB active connections while database is running online. On top, we see users making their own SQL queries via the database engine. On the left side, we see the DB2 data file being copied or tampered with, and users see cryptotext because data is encrypted. So again, we'll click on this example here. So on the left side, we see the DB2 data being copied. The GDE policy allows database engine to read and write to the database files in clear text, but any users who attempt to copy or read data files from file system will see the cryptotext. So let's click on the encrypted data to see the rekey statistics. And that is this screen here. Rekey statistics on the left window show number of files encrypted live, as well as the data file sizes that were encrypted. Live data transformation, or in other words LDT, can be used for initial data encryption and periodic encryption key rotation, in other words rekeying, which is usually a corporate policy as per compliance regulations dictate you should recycle or rekey the keys every 60 to 90 days. So by utilizing the live data transformation, this can be done without disruption to the business applications. So let's click on the LDT status to continue. The DB2 engine processes have all access to read and write to the encrypted data, so this will not do any business disruption to the DB2 application, the authorized application that needs to work with that data in the clear transparently. But system root users may see the data directory metadata, but cannot see the data file contents in the clear. There's no key to decrypt the contents. Policy is highly customizable. You define your scenario by processes, users, time of day, resources, and the effect when that action happens. So let's click on the OK button to continue. On this screen, you can optionally click on either policies to look at the details of the standard VIP policy and the LDT live data transform DB2 policy again. Click keys to see centrally managed encryption keys. Keys are managed with GDE. Each domain can have their own keys, their own set of encryption keys. For example, the HR domain has their own standard live data encryption keys. Finance or other departments may have their own set of keys for separation of duties. So let's click on log to see the log options. This screen shows GuardPoint access logs or DSM logs can be sent to QRadar or any other SIM via syslog. Logs can also be configured to send email notifications for selected messages. And this brings us to the end of the demonstration. Again, engage with your customer on their needs, their project timelines, executive sponsorship, and if timing is right, budget conversations are there. Invite your customers to spend some time with your CTP to do a deeper dive of the actual product code in a live demo. We have plenty of assets to walk a customer through the product, value deployment, operations, and if the need arises, a POC can be scheduled. Thank you.